Fehling's test is a biochemical test commonly employed to detect the presence of reducing sugars with free aldehyde or ketone functional groups, specifically alpha hydroxyketones. Reducing sugars include almost all monosaccharides, such as galactose, glucose, glyceraldehyde, ribose, and xylose, and some disaccharides, like maltose and lactose. During Fehling's test, a solution known as Fehling's solution is used. Fehling solution is a mixture of copper sulfate, sodium potassium tartrate, and sodium hydroxide in distilled water, which forms a basic aqueous solution of bis tartrato-cuprate 2 complex. This complex is quite unstable and readily decomposes. Therefore, Fehling's reagent is prepared fresh in the lab prior to the test from two separate solutions, labeled Fehling's A and Fehling's B. Fehling's solution A is an aqueous solution of copper sulfate, and Fehling's B is a mixture of sodium hydroxide and sodium potassium tartrate. For the test, both solutions are mixed in equal amounts so that the copper and the tartrate ions react to form a deep blue complex. The reaction that takes place may be summarized as follows. The copper sulfate reacts with sodium potassium tartrate salt under basic conditions to form the bis tartrato-cuprate 2 complex, known as Fehling's reagent. This complex is responsible for the deep blue color of the solution. Sodium hydroxide provides the basic conditions required for the redox reaction to occur between the reagent and the reducing sugar. Sodium potassium tartrate acts as a chelating agent and complexes with the cupric ions of copper sulfate, while the copper sulfate itself provides the copper ions which are easily reduced from an oxidation state of +2 down to +1. To prepare the Fehling's solution, first start by preparing Fehling's solution A. Weigh 8.65 grams of copper sulfate pentahydrate and dissolve in 100 milliliters of distilled water. Dilute the final volume to 125 milliliters, stopper the flask, and mix the contents very well by inverting the flask a few times. Transfer the solution into a container with a tight-fitting cap and label it as Fehling's solution A. Set aside and proceed with the preparation of Fehling's solution B. To prepare Fehling's reagent B, weigh 43.2 grams of potassium sodium tartrate and 17.5 grams of sodium hydroxide. Transfer the two salts into a volumetric flask and dissolve in 50 milliliters of water. Make up the final volume to 125 milliliters. Mix the contents very well by inverting the flask several times. Transfer the resulting solution into a container with a tight-fitting cap and label it as Fehling's solution B. The two solutions are mixed in a volumetric ratio of 1:1 to obtain Fehling's solution. To begin the test, add a few milliliters or grams of your test sample. We will be using butanol and acetone. Then, add 5 milliliters of distilled water, followed by 5 milliliters of the prepared Fehling's solution. Place the test tubes in a hot water bath for a few minutes. Once the hot water bath begins to boil, notice the color change. The formation of a red precipitate in the test tube containing butanol is a positive result, indicating the presence of aldehydes or alpha hydroxyketones. Whereas in the test tube containing acetone, the blue color persists. This is a negative result, indicating the absence of aldehydes or alpha hydroxyketones. The principle behind this test is simply a redox reaction where the aldehyde of the reducing sugar is oxidized under alkaline conditions to its corresponding carboxylate salt, while the copper 2 ions are reduced to copper 1 oxide, which forms a precipitate that can exhibit different colors. A positive test result is indicated by the presence of this precipitate, which is usually red. Some ketone sugars, like fructose, also give a positive Fehling's test. This is because fructose is an alpha hydroxyketone, which is converted by tautomerism into its corresponding aldehyde, therefore giving a positive test. Fehling's test can be also performed on samples suspected to contain non-reducing sugars. For this, take 2 milliliters of the sample, add 1 milliliter of hydrochloric acid, and boil the contents of the tube for about a minute. Allow the test tube to cool down and add some sodium hydroxide to neutralize the residual acid present in the test tube. Fehling's test is then performed as usual on this hydrolyzed sample, which is now supposed to contain reducing monosaccharides. To clean up, remove the precipitate by suction filtration, place the solid in the non-hazardous solid waste container, and discard the filtrate in the aqueous solution container. Finally, it is worth mentioning that before the discovery of the much more stable and improved Benedict's reagent, Fehling's reagent was the most widely used biochemical test for glucose in the urine sample of a person suspected of having diabetes mellitus. The test is now largely replaced by Benedict's test because of its convenience, stability, and ease of use.